We're at gotomath.com, and we're still talking about inverse functions, the introduction, and I guess I've decided to do a part 3. So there's a lot to talk about, believe it or not, even though it's a fairly simple problem to work. But anyway, we're going to be click on this button here to see this video. We're still talking about the function f of x here, because I think it's 2x squared in the problem, and we're just kind of generally talking about it. So this is a continuation from parts 1 and 2. So the idea was is we drew a picture of what f of x looked like, and then I kind of sketched out what f inverse looks like. And the whole idea is if we can find the slope of this tangent line right here, in other words, right, by taking the derivative of this function right here, right, that gives us basically geometrically the slope of the tangent line at the point when we plug b. When we plug b into the function, all right, we get a out. All right, now that's into the function. That's not the derivative. That's just into the function. We get a out. Now we're actually been given a. This is what they give us. And so algebraically, you can go ahead and solve for b in this problem. Now remember, take the positive because we'd be taking the square root here in this particular one. But that's not really what we want to do. We just want to kind of go through and plug 1 in, see if it's equal to a, plug 2 in for b, plug 3 in for b, plug 4 in for b, and so forth until we get this thing to be a, because this might be x cubed plus 3x minus 4, something that you can't factor or solve for x, okay? And so we just kind of plug some numbers in until we get it to equal that. Well, that was the whole idea, was to finding b, and once we were able to find b, then we could take b and plug it into the derivative, and that gave us the slope of this line right here. Now the slope of this tangent line, okay, this is what we're actually asked to find right here. We're actually asked to find the derivative, or the slope of the tangent line. In other words, what the derivative of the inverse, and plugging a in to it. All right, in other words, here it is, f inverse the derivative of a equals. Well, this is what we're actually asked to find, but since these are both inverse functions of each other, if we know the slope of this tangent line, then all we have to do is take the reciprocal. So let's say the slope of this guy we'll say is m, then I know that the slope of this line is 1 over m, okay, is 1 over m. So let's just look at that. So if I find the derivative, f prime of b, right, we discussed how to get b, we take b and plug it in, right, then that gives us the slope of the tangent line. But then all I have to do now is just go, oh, just 1 over that, and then that automatically gives us the slope of this tangent line at a. And that's it. That's all you got to know. Now a little bit about inverses and this formula right here. If we started with f inverse of f of x, okay, is equal to x. Now this is one of the things about if functions are inverses each other. If we take the function a composite f inverse composed of f of x, we should get out x. Also, if we did f of f inverse of x, right, if you compose of them just like this and we get out x on both sides, they're inverses of each other. But where we actually come up with this formula right here is by taking the derivative of this guy, and you're going to be taking the chain rule, doing the chain rule. So it's f inverse prime, okay, of f of x, and then chaining this out, and this is f prime of x, is equal to, and x is 1 right there. The derivative of x is 1, and then basically what's happening is we're taking this guy right here and bringing it down, even though something's fishy here. But I think I left something off. Hold on just a second. Actually, this is the one we want to use, and then we just take the derivative of this, as you can